Okay, before moving on to example 4 in your chapter 5, okay, there are a few important results down here, okay, which I want you to take note of. Okay, this kind of questions is very theoretical, it's very conceptual, so you may not be able to understand quite right now, but before you actually step into the exam hall in your A levels, make sure you understand this theory very well. So, okay, take note, okay, A and B are non-zero vectors. Okay, non-zero means that confirm not like that. Okay, this is what we call non-zero. So this is a zero vector, so it's not this kind. So if I say that lambda A is equals to mu B, and if I were to tell you that A is not supposed to be parallel to B, then lambda must be 0, mu must be 0. Or else, if they are supposed to be parallel, that means A must be maybe 1, 1, 1, B must be 2, 2, 2, or any other multiples of 20, 20, 20, or this is minus 1, minus 1, minus 1. So if in the first place, okay, they are non-zero, and at the same time they are not parallel, how else can they be equal? The only way out is lambda and mu must be equal to 0. Then similarly, if I were to extend the concept even more, and I say that lambda 1a plus mu 1b equals to lambda 2a plus mu b, and at the same time they are not supposed to be parallel. If we were to do a comparison, they cannot be parallel, these two cannot be parallel, the only conclusion is that they must be equal, then they can strike off one another. Okay, so spend some time internalizing this. It's not easy to get the concept in straight away. So let's move on to the next example 4. Okay, so in terms of question recognition, I want you to put asterisk to this question. This is a very important question when it comes to your exams, because this is a question that got no numbers. It's all variable based. Okay, so let's do some question recognition first. As far as questioning is concerned, recognize, variable based. Next, you see this. This is something that you learn in chapter 1. Okay, what it means is that basically this is very much to do with your ratio theorem. So if you need to roughly get your ratio theorem into place into a variable based question, the next important skill is sketch. Take note, this sketch will be super helpful for you to do it on your own. So my suggestion is not to look at the solution at all right now. Okay, spend some time reading this question, generate a sketch on your own rather than looking at the sketch that I've supplied for you. Okay, the sketch I supplied for you is purely for lecture purposes. Okay, so a lot of thinking, a lot of thought process has actually been bypassed. So my advice, draw a sketch on your own, pause the video, draw the sketch, see whether you can generate a similar looking diagram on your own. Okay, so that's the first task. Next, you need to understand certain things. As far as the question setting is concerned, there's nothing really much mentioned. They just say the lines PQ and the line OB are produced to meet at point R. Find the position vector of R. Okay, so these two sentences alone basically tells you they want the intersection of line PQ and the line OB. Okay, I repeat again, this section tells you that they want you to find the point of intersection between the line PQ and the line OB. Okay, so what you need to do first, of course, is to find the necessary position of Q, or position vector of P and Q in terms of A and B. Okay, so this section, okay, is basically your ratio theorem. I am not going to go through anymore. Activate your chapter 1 theory, chapter 1 skills, find OP, find OQ, and consequently find your PQ. So PQ looks like this. Okay, take note, this is vector PQ. What I'm going to write down now is the equation of the line PQ. Chapter 4 skills come in. Equation of a line looks like this. Okay, this is your so-called generic formula. R equals to A plus lambda B, where A is a point, B is the direction of your line. So pay attention now. Equation of line PQ. Give me a point. The point can either be OP or OQ. Okay, the point can either be OP or OQ. So for lecture purposes, I'm using OP. Okay, OP is here. I need a direction. The direction of the line is in the direction of PQ. PQ is here, so I copy down this whole thing. So this is A plus lambda B. 1 point, 1 direction. This is your equation of the line PQ. I'm going to do the same thing for the equation of the line OB. So equation of the line OB, same thing, follows this form. I need a point, I need a direction. So OB passes through origin, so the point must be 0 for convenience sake. Where is the direction of the line OB? It is in the direction of OB. So the equation of line OB looks like this. So your job now, as I said earlier on, is to find the points of intersection of the line PQ and the line OB. So from your earlier example, what I need you to do now is equate the 2 points, equate the 2 equations together. Okay, equate the 2 lines together. So this is your equation of the line here. Okay, line PQ is here, and the line OB. So if you look at this equation, okay, look at what I've copied down here. It's slightly different. So what actually I've gone through here is that I've do some rearranging of the data here. Okay, I have actually group all the A together and group the B together. So this is my line PQ, and then this is my line OB. Then what you need to do is compare A with the A, B with the B. So I generate another 2 equations. So from your equation, this one, I can solve for my lambda. From the lambda value that I solve, I can get my mu value. And subsequently, lambda equals to this, mu equals to this. And then you can back substitute back into either equation to get the so-called point of intersection between the 2 lines. Okay, this example, spend some time looking at it. It's very, very important because it is a question that students usually have problems with.